Hello, physicists, and welcome. In this session, we'll be looking at a parallel circuit that has series components. This follows the T5C2 series and parallel practice sheet, page 8. Let's get started. You have a two-branch parallel circuit. In the first branch, you have two resistors, R1 and R2. They need to be in series if they're in the same branch. And the second branch, you have one resistor. Let's go ahead and draw a quick image of that circuit. So I've gone ahead and drawn a battery here. I have one branch that has two resistors. These happen to be the specialized resistor called a light bulb, one after the other. Here's one branch, and the other branch has that resistor. Let's go ahead and draw this as a schematic. So I have my battery, light bulb, back to the battery. Put little circles around those. Yeah, the other one, I'll draw the more conventional resistor symbol, the zigzag, and then back to the battery. Let's label those with values. I see I have a 15-volt battery. What else information? I have R1, our first light bulb, has a resistance of 20 ohms, and our second light bulb has a resistance of 10 ohms, and we see that there are 3 amps flowing through R3. As we analyze this, let's keep in mind that in a parallel circuit, all the branches have the same amount of voltage across that branch. And in a series circuit, every element has the same amount of current. Hey, let's go fill out the table where we can. Hey, so I see I have 15 volts across the battery, which means I'm going to have 15 volts from this point to this point, and 15 volts from this point to this point. So across R3, I have 15 volts. Ohm's law will tell us anytime we know two of the three items, voltage, current, or resistance, we can always figure out the third. So let's go ahead and we'll complete this. Hey, my resistance is going to be equal to my voltage over my current. In this case, 15 volts divided by 3 amps tells us this branch has a resistance of 5 ohms. Next, let's take a look at branch 1. That's the branch that consists of both R1 and R2. We don't have voltage or current information. We do know that the current through R1 will have to be the same as R2. We also know that when we add the voltage on R1 and R2, it will equal 15 volts. That gives us some help here. And the resistance of the whole circuit from R1 to R2 along that branch will be the sum of R1 and R2 because series circuits add in resistance. So I see the resistance of branch 1 will be the sum of R1 and R2. 20 plus 10 is equal to 30 ohms. Yeah, I know what that total resistance is. Now I can figure out what my current is because I know from Ohm's law, I equals V over R. The voltage for the branch is 15 volts. The resistance for the branch, 30 ohms. My current through that branch is 0.5 amps. 0.5 amps, 0.5 amps. That's the same current that flows through R1 and R2. I'm going to add that to the drawing up here. So I see through that branch is 0.5 amps. Hey, I know two of the three items, voltage, current, and resistance for R1 and R2. Remember, Ohm's law applies to a circuit in general and each individual item. And let's go through and we'll figure out what the voltage on R1 is. Hey, so V for resistor 1 is equal to the current, 0.5 amps, times its resistance, 20 ohms. 0.5 times 20 is equal to 10 volts. Good, we got 10 volts there. Hey, for this voltage on R2, two ways to figuring it out. We know we have a 15 volts from above R1 to below R2. We've taken care of 10 of it, so we know the other 5 must come from R2, but let's verify that. So voltage on R2 is equal to the current going through R2, 0.5 amps, times its resistance, 10 ohms. I multiply those, I get 5 volts. 5 volts. Notice that these two values equal the voltage on the branch, 15 volts. Let's look at the current leaving the battery. The current leaving the battery needs to supply this first branch and this second branch. We have 3 amps going down the second branch, and we have 0.5 amps going down the first branch. Don't add the 0.5 twice. It's the same current that flows through R1 and R2. 3 plus 0.5 tells us that the total current is 3.5 amps leaving the battery. Hey, let's go and figure out what that equivalent resistance is. We can use that value R equals V over I. Let's do a quick calculation on that. See, I see the resistance of the circuit is 15 volts divided by 3.5 amps equals about 4.2 ohms. 4.2 ohms. Let's go ahead and do our power calculations. Remember, that's just going to be voltage times current. So 15 times 3.5, I get 52.5, and I'll put it up here, watts. All right. Let's take a look at R1. So that's the power or energy per time leaving the battery, and that gets supplied to our components, R1. Let's see, 10 times 0.5, I have 5 watts there. 5 times 0.5, I have 2.5 watts there, and 15 volts times 3 amps is 45 watts there. So 45 plus 2.5 plus 5 equals 52.5. Works out well. For the final section, let's take a look at the voltage versus position graph. I'll start on the negative side of the battery, which we'll call 0 volts right here. As I go one position, I'm at the positive side, so I raise the voltage 15 volts. Now from the positive side of the battery, I'm along a wire, so I stay the same voltage. Then I'm going to go along this first branch. So I'm at the same voltage for a couple positions. Then I'm going to drop over R1. That's a drop of 10 volts. So from this 15 volt position, I'll drop 10 volts, which puts me about 5 volts. I'll go one more position at 5 volts, then drop all the way down to 0 volts. Let's come back up here to our decision point. If we have a parallel circuit here, we'll have parallel paths on our graphs. Don't worry about the exact position on here. It gives us a pretty good idea of what's happening. Right? So beyond this branch point right here, we have a branch point in our graph, and then we drop across one resistor all the way from 15 volts down to 0 volts, and we're back down at 0 volts. We start at 0 volts, we end at 0 volts. If we have branches in our schematic, we have branches in our graph. As we drop 10 volts across one resistor, we drop 10 volts on the graph. We drop the other 5 volts across the other resistor or light bulb. We drop the other 5 volts on branch or on R3. We see that we drop 15 volts. Here, we drop all 15 volts here. All right. Hey, so for now, that's physics.